This might be a different day. I don't know if this one counts as day 4 or not. Let's see, what day are we on here? It was day 5 for the other one, but I think we started on that one. Well, no, maybe we didn't. No, Math 35 says lecture day 3 last time. Of course, that's me being a moron and labeling 2 different days, lecture day 3. So we are, in fact, on lecture day 5. And all of the day will be on R6, which is radical expressions and equations. If you want further review, well, I have some videos up on Canvas. I put in the announcements. Or check out chapter 8 on radicals in our johnblakely.com/textbook. So this is the nth root of A. Equivalently, this can be written as A to the 1 over n. That is called the index. Our great little radical symbol is called the radical symbol. And the traditional one is like that. I like having the little tail at the end because it shows you where the radical sign ends. And if you don't have something that indicates the end where it ends and you've got something listed after it, it's really confusing going, was that supposed to be under it or not? I'll show you an example a little bit, but you might like the tail thing. And then the thing inside it is called the radicand. What?
Radicand.
Right? Now, I will just frequently call this the inside. But it is the radicand. And it is the value such that if we raise it to the nth power, we get A. What does that kind of mean in symbols? If I have A to the 1 over n, or that, or nth root of A, and I raise this to the nth power, they both equal A. This one you kind of have to memorize, that's how it works. This one, we can do the math. We know the rules of exponents are multiply when it's like that. And 1 over n times n is just a to the first power. Yeah.
So this is, like, so the difference, this is if the exponent is 1 or something. Whereas if it was a negative exponent, it would be the,
We'll get to that. Negative means it's just on the bottom.
Yeah, it doesn't change its position of the fraction.
Right. This is assuming. All of this shit right here is assuming. That A is a number greater than 0. And N is greater than 0. So assuming they're numbers. If it's a variable. Not just A equals some known value. Then this actually turns into two things. If we have the nth root of A to the N, like that, if N is even, this becomes the absolute value of N. If N is odd, it's just N. And I'll show you why in a second. But we need a little bit more reminders of the rules. So we're gonna do that. Now that was just A squared or the nth root of A. In general, if we have the nth root of A to the M, like there's an exponent in there, this is A to the M over N. This is technically, I could write it as A to the M to the 1 over N power. And so when I multiply them together, M times 1 over N, I get that. But I could also switch this around. I could say A to the 1 over N to the nth power. And that's where we get the nth root of A inside the parentheses, and then the M is on the outside. These are all equivalent. So before I go into a little bit more detail, I need to give you a couple more rules on that. I just want to give you guys a little like refresher practice on what this shit means. Let's just do some examples. What is 36 to the 1/2?
6.
6. You might find this easier to rewrite as a square root of 36. Which is square root of 6 squared. Which makes me want to point out something, a little caveat here. If N is not listed, N equals 2. So this is really like a square root. You kind of want to make your radicals look like there's a ledge there. Because I'll show you in a little bit, it'd be confusing if there's something in front of it. Is that number there exponent on the number in front of it? Or is it part of the radical sign? You'll see what I'm talking about. But here the exponent and root cancel. And we just get 6. Another way of looking at this mathematically is, this is 6 squared, and the radical symbol is 1/2. And so this is 6 to the 2 times 1/2. which gets us to 6 again. What about the cube root or the 27 to the 1/3 power? This is the cube root of 27. Now, rather than going to your calculator, it might be faster once you get skilled at it, and it's definitely faster once you get skilled at it, is rewrite this in terms of prime numbers.
So like a factor tree?
Yeah. I did it in that last hour, but I didn't show the tree. This is 27 is 3 times 3 times 3. Which is 3 to the 3rd power, and so. We have 3 to the 3rd power. This is the n on here tells us what the bottom is of this exponent, 1/3. So 3 times 1/3 is 1. 3 to the 1st power is 3. Now, I want to respond to something that Davis asked about a second ago. With negative exponents. Negative exponents. And 0. X to the -2 is the equivalent of 1 over x squared. And 1 over x to the -2 is equivalent to x squared. So with a negative exponent. Just move it to the other side of the fraction. And it's important to recall that the exponent only applies to what it's hitting. If I have 3x to the -2, this is not 1 over 3 to the x squared. It is equal to 3 over x squared. Because the -2 exponent is on the x, not the 3. If you need a little more of a visualizer, that's 3 to the 1st power x to the -2. And you can see the exponent on the 3 is positive. Something that when you're rushing, you make that mistake and tell you, like, fuck, I lost points on the test for it. You don't want to be that person. Alright, so. With the 0 exponent. I'm gonna show you this in a way that you can follow pretty easy. If I have x squared over x squared. The rules of exponents say I can subtract exponents when they're divided. So this would be x to the 0. Just the same as if I had x squared times x cubed. This would be x to the 2 plus 3 or x to the 5th. So when you multiply, you add the exponents. When you divide, subtract the exponents. So this is x to the 0, but if we just simplify the fraction first, leaves behind a 1, this is 1 over 1. So anything to the 0 power is 1. Except x being infinity. And be careful with x equals 0. You will see this shit in calculus. It's called the indeterminate form. 0 to the 0 or infinity to the 0. I know. That's 2 semesters away. And it's actually not that hard. It's just something if you've never seen it before, it looks fucking like mind blowing. I think it's kind of like, I think if you kind of look at it like 0 to 0. Well, the rule says this is 1. But anything times 0 is 0. So what wins out? Which rule wins out? That's why does that make sense? And so in calculus, you'll learn more rules on. One of these isn't actually 0, one of these is going towards 0, which means it's not quite 0. It might be like 0.000000001. Which is really, really close to 0, but it's not 0.
So what is 0 to the 0 power? What is it?
Like I said, it depends.
Oh,
Depends on which one is going to 0. You won't ever see 0 to the 0 in any other way. Because they're conflicting. Don't worry about it. We're not gonna have that in this class. I'm just saying, there are exceptions. If you get 0 to 0 on your shit, there's an exception. Don't worry about that for now. Back to radicals. If we do -2 to the 1/2. This is negative square root of 2. Because the negative is not included with it. The only time the negative is included with the exponent is if it's in parentheses. That would be square root of -2. This is a real number. This isn't. It's called an imaginary number. Well, it's called a complex number. And we'll cover complex more a little bit, like 40 minutes or so. There's a lot of shit going on today. Lauren doesn't look like she's seen some of this shit before. I think I fucking didn't need to show you that 0 to 0. I think I got a lot of people fucking like panic in their eyes. Don't fucking worry about that shit. It's not right now. Just worry with fucking regular shit.
is that like when you get to like limits and stuff?
That's exactly what it is. It's limit.
Okay.
And it has to have like my graduate advisor told me the best definition of limits. Or like when something gets really close to a number, but isn't quite that number. Like a number really close to 0 that isn't 0, like 0.00001. He said that is like a martini, which is made with gin and vermouth. And it doesn't matter how little vermouth is in it, it's still a martini. Even if it's just 1 drop versus the rest of it being all gin, it's still a martini. It's called a dry martini. But as soon as that vermouth is 0 drops, it's just pure gin and it's undrinkable crap. That's how he described a very complex idea of limits. It's a good example. Let's see. The same can't be said for when we have an odd root like that. This is the cube root of -8. Which is the cube root of -2 cubed. This is going to be -2 as the answer. And it has to do, this relates to what I was just saying. Pull it back. This is in that n is odd category. Because this is also cube root of -2 cubed. It's in the n is odd category. Now, showing the n is even, we'll do that real quick. If I had, I'm gonna say square root of x squared, we'll do a square in here. This is the absolute value of x. Like up here, I said it was the absolute value of n. Here's the absolute value of x. And the reason why is if I plug in a negative number, like let's say x equals -6. Well, I've got the square root of -6 squared, which is the square root of 36, which is 6, which is the absolute value of -6. So we have the absolute value of x. So when we have an odd index, it doesn't matter. We can have negatives. When we have an even index, we can't have negatives, so we do imaginary or complex. But when we have when we have an even index, the same holds true with fourth root of x to the fourth. This is going to be the absolute value of x. It's any even index.
So any even index with like a negative number on the inside is just absolute value, or
We say absolute because when we don't know what it is. If it's already in, if we know exactly what x is, it's not changing, we wouldn't even have x in here. The key is that if x is changing. So like. If I had plugged in +6 instead of -6. I still would have gotten 6 here. Which is still actually the absolute value of +6. So the absolute value signs don't hurt if it's already positive. But it fixes it if it's negative. It's just a rule to remember. It's going to come up more in calculus.
what's the highest level of calculus you've ever taught?
Endgame calc,
What's that?
3-dimensional calculus.
Like
Calc 3.
Calc 3. My buddy is taking Calc 4 at Cal Poly. I don't know how he's doing. Shit.
Cal Poly might be on the quarter system, not a semester system, so
They are.
I'm sure Calc 4 there is 3-dimensional calculus. I taught Calc 1 and I taught Calc 3, and I'll be teaching Calc 2 in the fall. All right, a lot of rules to remember here. More rules. The nth root of a times the nth root of b is the nth root of a times b. The same holds true with division. Nth root of A divided by the nth root of B is the nth root of A over B. And before I do some examples with it, I'm gonna also throw in simplifying rules. A radical isn't simplified. If there's radical on the bottom. Fraction. The exponent inside is bigger than the index. And I'm gonna slap in a third one that isn't normally taught with radicals, but it's always true. We don't want negative exponents. Just talked about how we deal with negative exponents. I'll do this so it's clear, like that's the header sentence. Let's do some simplifying and then we'll throw in the multiplication and division. Because you kind of like, it's easier to simplify along the way when you're multiplying and dividing. So like if we have the square root of x to the 5th power, y to the 10th power, z to the 17th power. Let's say the 5th root, not square root, let's say the 5th root. The fastest way is to, well, this we can, same as we can put them together through multiplication. I can pull them apart. Now, I wouldn't normally do this step when I was doing the problem, but in terms of illustrating what's happening, you might find it helpful. Michelle, I don't think I'm teaching pre-calc B in the summer. I think I have math 44 and I don't think I have 54. That's a good question. Let me finish this problem. I'll look it up while you guys are doing the next problem. Alright, so the easiest way to do this is recognize this is x to the 5/5 power, or 5/5, y to the 10/5, and z to the 17/5. 5 divided by 5 is 1. 10 divided by 5 is 2. And 17 divided by 5 is 3 2/5. So this would simplify to x, y squared, z cubed times the 5th root of z squared. Because the tricky part here is this part. Let's look at that. Here, this is z to the 3 to the 2/5. You may not have thought about this in a really long time, if ever. But 3 2/5 is really 3 plus 2/5. And when we have exponents added, it means we can separate it by making a multiplication between them. So z cubed stays as is. The z to the 2/5 is the 5th root of z squared. And you see why having a ledge here kind of helps. If I didn't have the ledge here, we might be going, is that z to the 35th power and the square root? Or is it z cubed and then the 5th root? So the ledge helps. You guys ready for one?
Yeah.
Do the 4th root. 32 x to the 15th power, y to the 12th power, z to the 9th power. Simplify that. And while you're doing that, I will look up PreCalc B for you. Summer PreCalc B. Oh, I don't know if the schedule's live yet. I don't know. Let me see if my. Tell you what, I'll ask my contact here. PreCalc B is a little bit slower. This class slows down too, as soon as we get out of this review thing, we start doing more with each topic. This is stuff that you're presumed to know when you walked in, even if it's been a long time since you've seen it. Or fucking don't even remember it because you can go to class that day, but you still manage to pass the class. Or pass the class because the teacher gave charity grades, which happened during the pandemic.
Is that really going?
Yeah,
My high school had a way of like. So we went on spring break, right? And that was like when the pandemic happened. And it was said like, oh yeah, we're gonna be all good after spring break, but obviously that didn't happen.
right?
Anyways, our grades from before spring break, you could like, those were locked in, like if they went down, it didn't matter, like they would just take the higher grade. So basically,
Right.
if you had straight A's before spring break, you didn't have to do shit, you just had to,
Right,
you had straight A's, period,
which is terrible.
yeah.
I know they were doing a good thing. They didn't want to punish people that were trying to adapt to a different learning environment. But let's face it, students, children, young people adapt quicker and easier than anybody else. And especially in classes that go in sequence, handing out free grades just means they don't know what they need to know for the next step. You really just basically fucked them. They got a passing grade for that class, but you fucked them for anything else. And you fucked them good. And they didn't like it. Well, they did like it, but they shouldn't have.
So I got placed into, when I went to CLS, I got placed into, oh yeah, you can take calculus. And then remember I did,
Yeah.
and I was like, oh, I had that one,
And you
and here I am.
quickly and promptly identified that you shouldn't be there.
Yeah.
Not every student does that. They'll just take the failing grade and fucking fail and change majors. Like thinking they're too stupid. And it's not that. You're not stupid, you just didn't, you got a grade that you didn't earn,
Screwed over by the education system.
right? Alright, what'd you guys get for this?
Is it 32x cubed and then,
So here's one idea, 32x cubed.
and then you do like the fourth root of 32x cubed. Outside of that, it's y cubed,
Like a different radical,
yeah, no, not even a different radical, it's
just right here.
no, it's outside of the radical. Sorry, I messed it up, probably wrong, but this is what I got. And then z squared. And then the fourth radical z.
Anyone else get that? That's a fucking clusterfuck, I don't think anyone else got that. It's not right. But a lot of it's correct, it's just not cleaned up right.
Okay.
What is definitely off, this is not right. If I start off with a 32 on the inside, how do I still have it on the inside and on the outside? That's clearly a nope. So. Let's break it down. Anyone else wanna take a gander at this?
Yeah, 2x cubed. Y cubed, z squared. And then, the 4 radical sign. And 2. X cubed, I believe, and then a z.
Let's try it. Did you do that all by hand or you throw it in the calculator? Good. Calculate, a lot of calculators will do this for you, which is unfortunate. It's the lazy way out. You're not learning anything. If you do this smart, you do what I'm about to do when you're doing the homework, this shit will get easier with practice. And then you won't really be as reliant on a calculator, which is good. Cause you never see fucking people that are doing smart shit like engineering and shit, walking around with a calculator. You don't see it. Cause the only time they use a calculator is when it's something they can't do easily. And whether you can do this easily yet or not is just because you haven't tried it yet. Nothing's easy till you try it. So. That looks right, but I'm gonna do it myself. Let's take a gander at this. Let's do a factor tree on that 32 first. So 32 is 4 times 8. And 4 is 2 times 2. And 8 is 2 times 2 times 2. So all that is 2 to the 5th power. And then I got the rest here. I guess I made my radical sign a little bit longer than I really needed to. Now we'll switch it to those fractional exponents. 2 to the 5 fourths, x to the 15 fourths, y to the 12 fourths, z to the 9 fourths. Plus, doing this by hand will get you a little bit better working with fractions, which a lot of people hate. But usually it's just not a lot of practice with fractions. 5 divided by 4 is 1 1/4. 15 divided by 4 is 3 3/4. 12 divided by 4 is 3. And 9 divided by 4 is 2 1/4. So, anything with the whole exponent, we can strip and put outside. So I got a 2, and I'm not gonna put the 1 because it's a 1. X cubed, y cubed, z squared. And only things that have a fractional bit up here will go in the radical. And I have a 2. I have an x cubed, and I have a z, which looks like what you have. Now, ideally, you will remember that this should be absolute value of x cubed, absolute value of y cubed, absolute value of z squared, which actually, that one doesn't matter. But I'm not gonna mark you off on the test, like on the test, if you don't have the absolute values. I'm not gonna ding you for it. You can quote me on it if I fucking do ding you. Say, hey, you said. You say, go watch fucking lecture day 5, find yourself on the video saying you're not gonna ding me. That's a bad thing about recording this shit. Susan's gonna call me on my shit if I forget. Fun thing is, this one actually doesn't need it. Because doesn't matter what it was gonna be, whether it was negative or positive, squaring it was gonna make it positive anyways. But that's neither here nor there. That was practice simplifying. Notice I didn't use a calculator, just did some fractional shit. Practice with the fractions. And if you're not remembering what we're doing there, like the 15 fourths, that's just 4 into 15. Let me use the 9. Because we had a 3 left over above. 4 into 9. Goes in twice. The 1. So this is the whole number. And then the remainder goes on top. So 2 1/4. That's there. That's there. That's there. All right, ready for some more? Do another one. Did anyone need that longer? I see some pins moving. And here I am just yanking shit.
I was gonna say, aren't the absolute values supposed to be even numbers, not odd?
It was on even indexes. Not necessarily the exponent on the inside, it's the index. Good question. I think John Redden might be teaching PreCalc in the summer. I think. We'll see what happens. We already selected our classes, but like one person has that list and until the classes go live, He doesn't email it out to everybody and go, hey, this is what everybody chose. This is not that one guy.
Yeah, the one I emailed you to switch.
All right. How does this help us when we're doing something like? Square root of 15 times, I said square root, maybe I should put square root. Square root of 15 times, square root of 20.
If they become like the square root of 35.
Not 35. You added them. Remember we said this, they multiply together.
Square root of 300.
And if you multiply together and get 3, this is square root of 300. But that's kind of hard to work with. This is 3 times 5. And that's 4 times 5. 4 is 2 times 2. So I have the square root of 3 times 2 squared times 5 squared. Which means I can pull out a 2 and a 5 and it just leaves square root of 3 on the inside. Or 10 root 3. All right, let's take a 5-minute break. I know it's been close to an hour. I'll continue on. I think everybody's back. I didn't even actually ask. Well, I'll assume you are. It's been 10 minutes. Okay, we also had, maybe we should do a division one. Oh, we'll make it back, fine. Let's go big. It looks fucking ugly, doesn't it? Well, first rule is we can combine them all under one radical. And as much as you've seen 81 and 9 on the times tables, this is not x to the 9th. This is the square root of x to the 81 minus 9. You might instinctively go 81 divided by 9, because that's one of its divisors that most people know. And we had a division bar there. We don't divide exponents, we subtract them. 81 minus 9 is 72. And so you got 72 over 2, which is 36. And it's technically with an absolute value. And it just so happens in this case, we don't need the absolute value. Because even powers will, on the outside of an absolute value, make it irrelevant. What I mean by that is -2 to the 36 is the same thing as 2 to the 36 because of the exponent.
Is the exponent or the absolute value?
The absolute value is unessential here.
Okay.
If I just had this, they're still both 2 to the 36.
Okay.
So the absolute value, did you see how it's unessential at this point?
Uh-huh.
All right, like radicals. They have the same radicand. Index and radicand. or inside. And when that's the case, we can combine them. Tomorrow, this place is gonna have a lot of cops in it all day. Just so you know,
Okay.
they're doing officer training. So if you see a bunch of cop cars, that's why it was a couple weeks ago, they were doing a training. They're doing one again tomorrow. They're also doing the marketplace mobile pantry tomorrow. So tomorrow from 10 to 12, if you come here with your student ID, you get a bag of groceries, a bunch of groceries. They used to have like the Tulare County mobile pantry, you literally like take a wagon to your fucking trunk and like drop in 4 bags of fucking groceries. I don't know what they're gonna have tomorrow, but
At my class earlier today, and it was in Hanford, they just had a sign that said free, and it just had like romaine lettuce or like tomatoes and bananas, it's just like, shit,
Oh,
it wasn't a lot.
that nutrition to go or something, that was at the main campus.
generally they do the mobile pantry in different spots at the same time. I don't know what they're bringing them. But trying to make ends meet, free fucking groceries. And that's 8 to 10 tomorrow. No, 10 to 12. In the entryway, like right outside the door. Like radicals. So if I have something like 2 square root of x plus 3 square root of x. This is 5 square roots of x. That makes sense. Kind of like saying 2 apples plus 3 apples equals 5 apples. That may sound like dumbing it down, but you could treat it as an object. And you're adding up objects. That's your first example. That's easy move. Square root of 18y minus square root of 50y. Now, at first glance, these are not the same insides, right? But this is 9 times 2y. And that is 25 times 2y. Or 3 squared and 5 squared right there. So this is going to become 3 square root of 2y minus 5 square root of 2y. And we get negative 2 square root of 2y. All right, let me give you guys one to do. I ask you guys a question? When you log into Canvas, does it say there's assignments?
Well, I think sometimes,
It just says home. So,
Or homework? Does it say it without having to look at the modules?
What do you mean, like?
I know some like, when I haven't used ALEKS, I've used other things. It would have due dates and when students logged into Canvas, they would just have a list of shit that was due. And they would, half the time, they wouldn't even go in and look at the module and reach it, they just click on the assignment and not pay attention to instruction or anything. The reason why I'm asking is someone said they're in my online class. I assume the online class. And said it's been a couple of weeks and they still haven't received any assignments.
Those are automatically like in there.
Yeah, I put them in there and is it like, but is it,
They even, because like we have to where it shows like the modules that you have and it shows the assignments that we have. And it just says homework through midterm that's available. But that will take us straight to ALEKS, and then ALEKS shows us what it is that we have
okay,
assigned and when it's due.
yeah, it shows.
Because it won't directly take us to ALEKS, it'll just open a window.
the new site.
okay. Let's see.
But even if you go like on assignments. On it. It still shows like the upcoming assignments that you signed for upcoming with ALEKS.
Okay. So. I'm just making sure. I told the student that they're in there. Is it? Actually, I'm gonna show you guys and ask you on screen real quick. Is it annoying to have the lecture content, like the videos, before the homework stuff? Should I move the homework up? So it's above the lecture videos? Okay, I put it at the top. I still want the orientation video on top. Because. We'll look at it for shit. All right, so. This is 36 times 2. You may not recognize that. You may have done 9 times 8. But that part should simplify. I'm gonna keep it separate from the 2x squared y real quick. 6 times the square root of 2y.
yes,
And this part here, that's 9 times 2. So this should simplify to 3x squared y times the square root of 2y. So we're gonna take that 2 and multiply it with 6. Now, in this case, when we have other stuff beside the radical, these are like terms because of all the variables. Like, for example, if I had 2x square root of z plus 3y square root of z, they don't combine. Even though they both have the square root of z, the x and y are different, so they're different terms. I wonder if they do the big old Tulare County food truck or not. They do, that's a lot, they give out a lot of shit, a lot of groceries. When I was a part-time teacher adjunct, don't make a lot of money, and I picked up groceries 1 or 2 times. One time they had someone walked a wagon to my trunk to put it in. And they had, part of it was fucking like 5-gallon jug of mustard. I'm like, what the fuck? Like they had so much extra mustard in 5-gallon jugs. Before it goes bad or anything, they were giving it out, the factory that made them was giving them out. I'm like, who the fuck goes through 5 gallons of mustard?
Last month they were giving away like tons of frozen pizzas at the Visalia.
No shit, should be the same thing out here.
You know, the store thing.
The giant market.
Yeah, they've gotten like a pallet of these frozen pizzas.
I gotta put up links to that. I got links to the video for the giant market and the giant threads. Because if you're not familiar with it, they're both really good options for students. Free clothes and free food.
Giant threads is real.
I know it's real.
Nice. So it's not,
Is there nice stuff in there?
yes, nice stuff, yeah. It's not bad.
Alright. Power. We actually showed multiplying some of that stuff. Let's kick up multiplying a little bit more. Let's say we have the square root of x times the square root of x plus the square root of 3. So we're gonna do just like we did with regular distribution. This would be square root of x squared plus square root of 3x. Or the absolute value of x plus the square root of 3x. Overload, huh, Sarah? Like serious overload. I think this is the last really like action-packed day. Everything else is gonna be slower. We're just covering a lot of content today because it's considered review. And if it's been a while, it's gonna take some work for you. If we do square root of 6 plus 5 times square root of 2 minus 3. We do our normal distribution, we get square root of 12 minus 3 square root of 6. That's the square root of 6 hitting both of them. And then if the 5 hits both of them, I've got plus 5 square root of 12 minus 15. These are all as simplified as they can get, but this is 4 times 3, which means that's going to be 2 square root of 3. And then I still have the rest. And that, none of them combined, because they're not alike. I wanna make it very clear. This is not square root of 3x squared plus 2 squared. They are not the same thing. You can't just distribute the exponent because there's a plus sign in there. The plus sign screws up distributing exponents. But what that means is this is really this. And we will still see the square root of 3x squared. And we'll still see the plus 2 squared. But we also have a plus 2 root 3x, and plus another 2 root 3x. So this squared is 3x. Those combine together to make 4 square roots of 3x. And that's plus 4. And this is why I put the little tail on it. Tail helps here. If this said this. Like. Is that plus 4 supposed to be under the radical? Is it supposed to extend? Does it actually drop right there? Is the square, like what's included in the radical? This is a little unclear. And that shows that it's what it is. Let me give you guys some ones to do real quick. Assuming a little longer than would have liked to ask about homework, but I've had students. Wait for like 6 or 7 weeks. And they go, are we gonna have any homework? Like. Alright. So if we distribute. I got. 5 root x times 5 root x. Ends up being 25x. Because the square root x cancel and give you x. And then if I do these two, I have minus 10 square root of xy. And then if I do these two, I have plus 10 square root of xy. If I do the last two, I have
Or Y,
minus 4y.
two in the middle cancel out. The one,
2 in the middle do cancel out.
25x minus 4Y.
Yes. This is very much started out as an a plus b times a minus b. That's our difference of squares. What the good shit is, notice there was fucking radicals all over this motherfucker. And now there's none. These two, a plus b and a minus b, are called conjugates. Conjugates. And when they multiply together, they give you that difference of squares, but they clear radicals, they clear square roots, I should say. Not just radicals, but they clear square roots. They will also actually clear complex or imaginary numbers, as we're going to do in a little bit. And when the complex numbers are involved, they actually call it complex conjugates. But it's the same idea and it works the exact same fucking way. This conjugate stuff idea is how we can clear radicals in the denominator. Bottom, I should say. Now, I showed you earlier a division problem that cleaned up really nice. If we look at division, some of it does still clean up nice. We saw that, we did the x to the 81 over x to the 9th. We did this earlier and we got absolute value of x to the 36. That's because they were both x's. What happens when we have square root of x over square root of y? When we simplify, we can't have radicals in the denominator. The idea here is this is y to the 1/2. I wanna multiply by something over something. So that I end up with on bottom. Y to the first power. So what I need to do is multiply by y to the 1/2. So here, this would be square root of y, and that would be square root of y. We have effectively, this equals 1. So we're multiplying by 1, and we haven't changed the value. But now the simplified form is xy over y. If we change it up, make it ugly. Maybe let's do 7 on both indexes. No, let's just keep them separate. This is worth pointing out as well. This is x to the 4/5 over y to the 2/7. What do I need to multiply so that I end up with just y on bottom?
Five, seven.
Y to the 5/7. So up here, we just multiply it by itself, but that's because it was a square root. That doesn't work when it's a different index. So we did it on bottom, we gotta do it on top. And I can't combine these as is. This is still 5th root of x to the 4th times the 7th root of y to the 5th. The way we could choose to combine them is get a common denominator. So this is, you have 5 root x times 7 root y. I'm missing a fucking exponent there. X to the 4th and y to the 5th in here over y. And if we treat that as x to the 4/5, y to the 5/7 over y. 4/5 and 5/7 to get a common denominator, multiply by the other denominator. This is 20 over, oh, I didn't do what I said. Multiply by the other denominator. It's 28 over 35. And this will be 25 over 35. So that is the same thing as x to the 28/35, y to the 25/35 over y. If you want to combine them as one radical, that's what you got to do. This is the 35th root of x to the 28, y to the 25th, all divided by y. I don't plan on doing anything like that on the test. I don't know if the homework has anything like that. That is how you combine radical stuff that have different indexes. Alright. So that's divided by stuff that doesn't have a plus or minus in it. When we have a plus or minus in it. Don't go to sleep on me. This is where we have to do the conjugate thing. The square root of x plus square root of y. And I'm gonna put these in parentheses. I wanna make it clear that everything's getting multiplied there. And whatever's on bottom needs to be on top. This is the conjugate. Of that. So I get square root of x squared. Plus square root of xy. Plus square root of xy. Plus square root of y squared. And on bottom, the difference of squares is that. And I haven't cleaned up anything yet, but. The top is gonna have x plus 2 square root xy plus y. And the bottom is just gonna be x minus y. Busy couple first weeks as you get to get a lot of the review in. Especially if you haven't taken math like last semester or something, if it's been a while. You got questions, you email me, remember I'm in the Mesa Center. From 9 to 12 on Saturdays, so like you can fucking find me in person. On the weekend over in Visalia. I'll post info about it again this week. I want you guys to pass. Alright. So earlier I said we couldn't do anything with the square root of -2. Square root of -2 is the square root of -1 times the square root of 2. We can do every negative number like that. I can say square root of -x equals square root of -1 times the square root of x. Well, we have defined this as the imaginary unit I. Engineers use J. Because in engineering, I means current. It's electricity. Amperage. You think they would have been someone they figured out this. They were different, just use fucking switch everything to J. But they didn't. For your memory. So I is the square root of -1. I squared is square root of -1 squared, which is the absolute value. Nope, it's just -1 there, sorry. This is treated as -1. Then we do I cubed. This is I squared times I. So we have -1I or negative I. And then I to the fourth is I squared times I squared. -1 times -1. It's +1. If I do I to the fifth. This is just I to the fourth times I. And I to the fourth equals 1. So this is just I. So this is cyclical. If you want to simplify a really large I exponent. I to the 99th power. Just divide the 99 by 4. And look for the remainder. This goes in 24 times. I'm sorry, 24 times. That's 96. With a remainder of 3. This simplifies to I cubed. And I cubed is -I. So this up here, we would say square root of -2 is I root 2. We tend to put the I in front. It looks weird afterwards, which is funny because of what they describe as the next step. I put the little tail on my eye so it doesn't look like a 1. That dot can be really invisible. And if you just draw a straight eye. All right. That leads to complex numbers. They are, the standard form is A plus BI. Where this is the real component. And this is the imaginary component. All right, so. Playing with them. They work like working with radicals because they are radicals. They are radicals, so like. 5 plus 3i. Minus. 2 minus 4i. We combine things that are alike. The 5 and the 2 go together is 5 minus 2. And the 3i and the -4i go together. I have a 3i minus a -4i. So this ends up being 3 plus 7i. Like from R6 is gonna bleed over into Thursday's lecture. This is a fucking long section. We haven't even gotten to the equation part. Right? That's a special kind of hatred. You're gonna really fucking not like me that day. Alright, so adding and subtracting works kind of like normal. We add the things that are alike. That's what we've been doing all along. If we multiply. Multiply an imaginary times a complex number. This is 6i plus 15i squared. Because I times I distribute. But I squared is -1. So this is 6i minus 15. And to write it in the normal form, we do it the other way around. -15 plus 6i. So this should obviously work similar when we scale it up. 2 plus 3i times 5 plus 4i. We're just distributing again. Three times 5 is 10. 2 times 4i is 8i. 3i times 5 is 15i. And 3i times 4i is 12i squared. So this is -12 here because the I squared is -1. So when we combine like terms, I've got 10 minus 12 plus 8i plus 15i. So this ends up being -2 plus 23i. You know, it's a lot. I know it's a lot. I know it's a lot.
Not bad. Is C used?
It's tedious. I'm gonna do one last thing real quick. It's related to division. Just so we finish up this complex number thing. We do the conjugate again. And I just did this shit on top. This one on top was -2 plus 23i. We just did this up here. The bottom is 5 squared minus 4i squared. Which is 25 minus 16i squared. But I squared is -1, so this ends up being plus 16. And those add together make 41. All right, that's it. Godspeed. Oh, it says 5 o'clock. I apparently didn't go over. We'll do some more this chapter, this section on Thursday, go over some equations real